Libgdx is an open source project. We're on GitHub. If you can't read this, that's 300,000 contributors. No, I lie. We are an open source project and we're very active. I tend to ignore the issues and pull requests that come in and delegate that off to other people. But here are some statistics. Oh, great. Those bars go all the way to the end. I don't know if you've heard of AppBrains, but basically they're a statistics website that kind of trawl through Google Play and look at what kind of engines and frameworks go into the apps. So take it with a pinch of salt. But these are market share for the Google Play Store. We're trumped by Unity 3D and Cocos 2DX. Anyone use Cocos 2DX? Boo. No, I joke. So we're a relatively mature project, despite our developers. We're at 1.7.0 at the moment. Snapshots are built on every commit, so if you have an issue and we solve it, put yourself on the snapshots and you'll get the very latest and best. And you're free to fork us, steal all our code, don't do that, and then push back. We really love people to contribute to the project. So an overview of Libgdx. We are a game development framework. Most of the framework is written in Java, but we have a lot of C and C++ components for the performance-intensive parts. So things like our bullet wrapper and our and Box2D, and we've got a lot of native libraries as well for each of the individual platforms. And we have some JavaScript, oh god, for the web backend. So we are a framework rather than an engine. So a lot of people have their own definitions of what a framework is, but how we perceive it is that a framework shouldn't try and do everything for you. It shouldn't force design concepts on you, on patterns. You have the foundations, you can build on that, and just go to town with it. So bear in mind, it's not going to do everything for you. You have to do a little bit of work. Saying that, as I'll come on to in a second, we have API layers, and at the highest level, you can basically build a tiny engine on top of it. So it's very fast for development and prototyping. Lots of people use it for game jams because of that. You can use any JVM language that you want. There are some caveats to that. It's super fast, especially on Android. We have a multi-layered API, which is ranging in difficulty and complexity. So you can go in at whatever level you feel comfortable. You can target multiple platforms with a single code base. We did that before it was cool. Everyone seems to be doing that nowadays. And we have an extensive community of developers. The forum is very active, not just for Libgdx specific problems. If you've got any game design questions, there's always people out there to help you. So what platforms do we support? Windows, Mac OS, Linux. Oh, you can only see a little bit of him. Android, iOS, and half of the web. So if you have like a BlackBerry device or Windows phone. Does anyone have a Windows phone? One person has a Windows phone. That's about right. Oh no. That's Windows phone for you. You can use the web port for those, and it works pretty well depending on how complex your app is. So people tend to code with Libgdx with Java. Java's great. Who are Java developers here? Preach. One person. Okay, are there any like hipsters out here who uses like Clojure or something weird? Scala, Python? No one Python? That's surprising. Well, you can use any JVM language that you want. So if you are a hipster, you'll be okay. As long as it has proper Java interpretability, you'll be great. You'll lose support of HTML because of how we compile for the web. More on that in a little bit. So here's an example of some API usage with Python and with boring Java. So it's very similar. So when you're looking at other source code, you can just copy examples and the syntax is identical. So the development environment, our setup tool generates our setup tool generates Gradle scripts. If you're not familiar with Gradle, as you aren't Java developers, basically binds the project together with all dependencies and fancy tasks and things like that. But it allows you to use any IDE that you want. So IntelliJ IDEA, Eclipse, NetBeans, or if you really want, you can go to the command line and use Emacs or Vim or whatever hardcore tool you use. So the standard development environment is that you would test your game or your app on the desktop platform. It's faster to launch. You don't have to upload APKs or IPAs to your phones. And you get to use all the fancy features of the JVM, like hot swapping, if you want to fine-tune things in your game. And then you can just deploy to all the platforms with an easy task. So has anyone used Java before? OK, a few people. So Gradle is a build tool. It's a dependency management tool, and it basically handles your projects for you. Maven is very similar, and Ivy, although Gradle's the best. It's open source. You can use it to build your Libgdx project. You can use it in the background, or you don't have to use it at all. We don't force that on you. It's just the default way to generate a project. But if you use Gradle, it makes it easy to keep up with the latest release of Libgdx. We're always making changes, always pulling in new features. So it is really good to keep up to date, and then you'll avoid API breakages later on. People always come to the forum with a weird problem, and we ask them, oh, OK, what version of Libgdx are you running? And it'll be one from like 3 years ago, because they're too lazy to update the jars. But now we have this nice thing, so you just put in a new number in a build script, and away you go. So one of the really cool things about Gradle is that you can extend the scripts that we generate for you to do tasks that really I hate doing. I don't know if anyone else hates doing this. But for example, if you're deploying to multiple app stores, so if you've got the Amazon store or Google Play, I hate their web interfaces so much. When you upload an APK, you have to go to every single site, make sure the versioning's right, push it like manually. I'm too lazy for that, so I write a script that will use their API, automatically upload to every single targeted store that you want. It really is the lazy way out. So same goes for descriptions and assets on multiple App Store pages. And if you want, you can push your project onto continuous integration, so you can build it live with commits. So one thing that I did with a game jam was that every commit that I'd push, it would build a live HTML version. So anyone that was lame enough to follow my development could see a live version of the game as I was doing it, broken or not. So how do we actually target all these different platforms? So on Android, it's just stock Android. There's nothing interesting about that. We use native libraries for GLES bindings. It's GLES 2.0 under the hood. For the desktop platform, we use the lightweight Java game library. We're on 2.9.2, I think, at the moment, and that helps us support Windows, Linux, and Mac OS. We use the OpenJDK on Linux, and that's OpenGL 2.0 and 3.0 under the hood. 3.x is in development, which is going to support Vulkan, so that's going to be exciting. On iOS, we use a project called RoboVM. Has anyone heard of RoboVM? Nice. So RoboVM is really awesome. Basically, it compiles Java bytecode to native ARM and x86 code. So these guys are actually magicians. They compile a small VM based on Android with your package, and it's still only like 10 megabit when you push it to the store. For the web, we use the Google Web Toolkit, and that compiles Java source code to JavaScript. Reflection isn't supported on the Google Web Toolkit, so we've actually got a wrapper in Libgdx to help you use to help you target and use reflection without breaking the web. And we also have a headless backend, which is really boring. It's just a standard Java. So if you want to push it, if you want to have a server-side component to your app, people use headless, or you can just run your own Java applications. So the library can be roughly split into API levels. We've got low level, mid level, and high level. These range in different complexities and the features, really. So at the low level, we have all our graphics interfaces. So OpenGL ES 2.0 and 3.0 are there. We've got all input handling, so keyboard, mouse, touch, accelerometer, gyroscope, all those lovely mobile things. We handle all audio reading and writing and decoding and encoding. Most of the time, it's OpenAL implementations. But on Android, we have Android pools. Has anyone had like a flawless go with Android audio? Because it is terrible. I don't know what they're doing with that. We've got networking, TCP and HTTP, and also HTTPS silently. We have all file I/O, reading and writing to your device. And we also handle the life cycle. So on Android, when your device goes into pause, when it gets destroyed, or when it's resumed, there are certain contacts that need to be reinitialized, and that's handled for you. And our reflection wrapper. So the next layer, we have the mid-level. So the mid-level is built on top of the low level. Most people use Libgdx at this level. It has most of the useful features people tend to use. So we have GL abstractions like mesh, shaders, texture sprites, all handy objects that are easy to manipulate and handle. We have batching of sprites and polygons. So this is one of the things that helps keep Libgdx really, really fast. And it saves you lots of GPU instructions. We have support for bitmap fonts and texture atlases. No more texture swapping. And it makes it a lot easier to handle all your assets. We have the asset manager, which handles synchronous and asynchronous loading of assets, so that's sound, textures. You can write your own loaders for different formats. Anything that will be loaded asynchronously will be. Some things require the main thread still, so textures, for example. We have custom collections, because Java collections tend to generate a lot of garbage, and if anything Android hates, it's garbage. So our custom collections are really quick, and they generate no garbage. So the internals of Libgdx are really quick, no garbage, keeps Android nice and happy. We have JSON and XML serialization and deserialization built in. If you want to save game data, entity states, getting stuff from networks, this is your go-to. We have utility classes, whole math library, and shapes library. So that's vectors, quaternions, intersections, collisions. You can make your own tiny little physics engine with 2 Java classes if you use these util classes. And then we have the high level. So that includes extensions, which I'll talk a bit more on later. So some of those are Box2D and bullet physics. We have a full 2D scene graph and UI toolkit. We have all the widgets. They do belong to us. We have a maps API for loading tiled maps, if anyone used tiled application for tile maps. And any proprietary tiling software, you'll get support for it. We have the 3D API and the localization bundle, so you can translate your app into loads of different languages really simply. So the 3D API, it's relatively new, and it just got refactored. So we've got support for environment, so that's cube maps, reflection, specular, normal mapping. Directional lights, point lights, spotlights, shadow mapping. There's actually a giant PR on our GitHub at the moment that, not refactored, but we've got a whole new lighting system. And it's a really cool system, probably one that we're going to pull in relatively soon. We've got a full node tree, including animations. They don't have to be skinned, but GPU skinning is also there. We've got decal batching, 3D particles, and probably the most complete Java bullet wrapper for 3D physics, bullet TM. Don't quote me on that. So extensions, they're more like libraries, but we call them extensions. There's no format that you need to do if you want to write your own extension. You can just download and plug it in, and they'll work. So we've got Box2D. Everyone knows Box2D, 2D physics engine. We've got Box2D Lights, which is a really awesome raycasting lighting engine built on top of Box2D. We've got Bullet Physics, which is 3D physics, really awesome 3D physics. Look at all the balls. We've got Ashley, which is a really lightweight entity component system. If anyone hasn't tried entity component systems before, I definitely recommend it. Really cool stuff. We've got a tools collection. More on that in a bit. We have controllers extensions, so support for Xbox 360 controllers, Ouya, any controller that you can provide a mapping for. We have an AI extension, which includes pathfinding, decision-making, state machines, behavior trees, messaging, movement, formation, motion. And we have a pay extension. So this will handle in-app billing on, I think they support 8 different platforms. So Amazon, iOS wallet, web wallet, Google Play. And this all does it so you can do it from your core code without handling any platform-specific code. So some of our tools. We've got a texture packer, which allows you to pack all your textures into one big texture. rather than texture swap all the time. This is really good because you just hand it to artists. You just hand it to artists to run, and they don't have to worry about doing this. We've got a model converter, so that converts 3D models into Libgdx-friendly models. So it supports Wavefront, OBJ, and FBX, and I think a few others. We have FreeType, so dynamic loading of TrueType fonts to bitmap fonts on the fly. So you can generate any size bitmap font that you want for your specific device. So if you want really crisp fonts, this is the way to go. And we've got 2D and 3D particle editors. And as you can see, that lovely swing interface. Yeah, it's great. So we have third-party extensions. We have loads of them. These are just a few of the examples. So if you're more into the whole what you see is what you get editor, where you drag and drop things, make compound objects, Overlap 2D is really good for that. So it's an open source game UI content editor. And you can make all sorts. Compound objects, join sprites together, add script to them, send out events, import skeletal meshes from some third-party skeletal framework, whatever. It's really cool. We also have VisUI, which is a UI toolkit that extends our inbuilt UI toolkit. Our default skin for the UI toolkit is awful, so I'm not going to show you what it is. But this one provides one, so you don't have to look at it. So the quick start guide is really simple. You just go on our website, make sure that your development environment is set up. There's a lengthy guide on this if you need it. Download, choose the extension and things. You can see a little bit of them. Desktop, Android, the font's tiny. And all the extensions that you want. And there are third-party extensions in there as well. So all you have to do is tick certain boxes, and it will generate the project for you. And then you import it and run, and it just works. So he says. Documentation and source. It's all on GitHub. If you import your project into your IDE, it's also attached, so you can just scroll through your IDE as is normal with Java applications and just run through the source. The wiki is the ultimate guide for everything. Definitely recommend you doing that. And there's also a starting point for documentation, which includes videos, if you like videos, and all that fun stuff. So licensing and costs, it's absolutely free. It's Apache 2. You can do what you like with it. You don't even have to give us any credit. You just use it. If you do release it, let us know. That'd be cool. And give us credit if you want, but it's not mandatory. So some of the games that are made. This is Alchemist Awakening by Osiris Games. I think they're a Polish development team. They just recently got greenlit. This is like a procedurally generated 3D open world game where you're like this wizard and you set fire to cats and things like that. I think they're adding online support as well, which would be kind of crazy. Ingress, has anyone played Ingress? That was a Google startup. They use Libgdx for their Android and RoboVim and iOS build. Halfway by Robotality, guys from Germany. Has anyone played Halfway? Anyone like XCOM? If you do, I definitely recommend this. You can get it really cheap. Really cool game. Spine. Everyone must know Spine. Who knows Spine? Okay, a few of you. If you want skeletal animation, Spine is pretty much the software to go to. This is actually built by a Libgdx developer. I'm not getting paid to say this. And it's built with the Libgdx framework as well. But this doesn't just export to Libgdx. You can use it in Unity, I think Corona. There's like 10 different runtimes. Gunslugs 2 by Orange Pixel. Procedurally generated platformer shooter runner. Really cool fun. And Delvo by Priority Interrupt. So it's a 3D, kind of 2D decal rogue game. But that's really cool as well. Definitely check these out. So there's loads and loads of games. We have a game submission on our site, which has, I can't remember, something like 900. But hardly any people push to that. There are loads of games out there. These are just a few. So that's Libgdx. You can find us on that L, but just Google it. No one takes down these L's anyway. If anyone uses IRC, we're on Freenode. So if you want to pretend that you're working, definitely join us. And you can follow Libgdx on Twitter and that thing, if Twitter's your thing as well.